This is our third rigid motion, rotations. Rotations are a composite of reflections over two lines. This time the two lines are intersecting instead of parallel. If they were parallel, it'd be a translation. If they're intersecting, the end result is a rotation. The rotation, it has a cursive R, so I can know it's different than reflection. It's a composite of two reflections. I'm going to go, my reflection is going to be M and then L. M, then L. I look at the acute angle between them, and if I drew an angle or drew the rotation M towards L, it is counterclockwise. So I know that my rotation is a positive angle measure. I measure that acute angle between the two lines, and this isn't lined up so great, so I'm going to measure the vertical angles. Remember, vertical angles are congruent. This looks to me, center of the protractor to 0, looks to me like it's a 28-degree angle. That means my rotation is going to be a 56-degree counterclockwise rotation, positive 56-degree rotation. So, let's do this with reflections. I'm going to reflect over M first. Don't know why that point's there. Put my compass on F. Forget about L. Spin my compass for M. Find the two places I hit M. Find my perpendicular bisector. Make it a little longer here. This will be my F prime. Same thing for point L. Open it up. I'm reflecting over M. Find the two spots it hits my reflecting line. Two spots it hits my reflecting line. This becomes my L prime. Do the same thing for A. Reflect over M. Oop, didn't make it big enough. Reflect over M. From these two spots, find the point on the perpendicular bisector. That's A prime. Now I'm going to use a ruler for G, just so that you see it all different ways. I have to make sure that my line, my ruler, and my reflecting line are perpendicular. So I put my compass and my protractor on each other. Slide it right to G. You can check it again if you want to. Okay, I line my ruler up at 7. It looks to me like it's 2.9, or I'm sorry, 1.9. So it looks to me like G prime is going to show up there. I've reflected the important parts of my shape. Figure reflection theorem tells me I have to just reconnect those important points, and I'll get the reflection of the whole figure. So this is flag reflected over line, reflecting line M. Now I want to reflect this new image over L. I did M, I'm going to forget about it, and now do L. On this one, I'm going to use my ruler, because I have all sorts of crazy arcs going on. L is here. That's perpendicular. Line my ruler up. Get the contraption so that my ruler is right there. Put it on the 5. Looks to me like it's 0.6. 0.6 is here. So this is where my second reflection goes for F. I'm going to do the same thing for L. Make sure it's still perpendicular so I'm not twisting it around by accident. Get it to L. Measure the distance. Looks to me like L is almost 1. Almost 1. Here's L. That's L double prime. Do the same thing for A. Again, make sure, the hard part about the ruler is making sure it's still perpendicular. That's where you slip up. The hard part about the compass is that you start to get too many lines to look at. Okay, I'll move it down to 4. A is 2.1. 2.1, almost my broken piece. That's A double prime. G prime Again, it's going to be perpendicular. Make sure I get it perpendicular. Line up at 5. This is 6.4, 1.4, 1.4. There's my G double prime. So if I connect my F double prime to my A double prime, then connect my L double prime to G double prime, and my A double prime to G double prime, I will get the second reflection. So this shape right here in red is the final result of my two reflections over the intersecting lines L and M. Now I want to name it correctly. At the beginning I said it was P-O-S-T. F matching with P, F double prime, call that P. O matches with L, L double prime is my O. S with A, and T with G. That is my rotation of 56 degrees in a counterclockwise direction. Now, just to eyeball it, to see that I did it right, I'm going to, on my clear sheet, trace FLAG. I'm going to put my point of rotation there. Now, that's another nice thing about the compass is I can stick it through more than one piece of paper, and I can rotate this shape, and it will land on my other one. And if I measured this rotation from here to here, it should be 56 degrees. If I measure the rotation from here to here, it should come out to be 56 degrees. From that center, 56, right there.